we've spent a lot of time talking about equations where this side is equal to this side. But you know, math is about patterns and relationships, and some of those relationships don't always work out so nice and neat and tidy. So we say a lot of things, just common everyday things that are comparisons that mean two things are not equal, that one is more or less than the other. For example, I might say, I know I have at least $350 in my bank account. That would be a comparison. Or I could say, I can spend no more than $50 on a birthday gift for her. Or I might say something like, I have at least enough food to feed 6 people for dinner tonight. Something like that. So those comparisons are not saying that this is equal to this. They're saying that one of these is bigger or smaller than the other. Now they can be equal to each other on occasion, but that will be that's a separate situation, and we'll talk about that in just a second. So all these equations are equal to. But if we have an inequality, hopefully you know from your language arts class that the prefix in means not. So this is saying that we are talking about things that are not equal. And if two things are not equal, that means one of them has to be bigger or one of them has to be smaller. So if you look at the chart on your paper, you will see there are 4 math symbols that we use. And the first phrase in each of those boxes is the most well-known phrase that matches with that. So if you see it, a arrow pointing to the left, that's our less than sign. If it's pointing to the right, that's greater than. Now if it's pointing to the left and it has a little line underneath it, that means less than or equal to. So this is one of those cases where we can say it could be that number or it could be less. Something like, let's see, if you want to eat from the kids menu, you have to be 12 or under. That would be a situation where you would use this. So you can be 12 or you can be less than 12 and you can still eat for those prices. And then we have greater than or equal to, which means you could be that number or it could be something higher. So my example of at least, if I say I have at least $350 in my bank account, that means I could have exactly 350 or I could have something more. Could be a little bit more or a lot more. Just depends on the situation. So let's go down here to these 4 at the bottom. Now these are just in terms of words, and we're just going to put one of these 4 symbols in the box. So it says no more than 200 people can be seated in the restaurant. So the two things we're comparing are the number of people seated in the restaurant and 200. So we have to get those wheels turning up in the brain and think, could there be 200 people exactly? Can there be more than 200, or does there have to be less than 200? So the number of people seated in the restaurant, from this it says that it could be 200 or it could be less than that. So no more than. And that's going to be less than or equal to. So the number of people in the restaurant is less than or equal to 200. So go ahead and fill that in along with me as we go through. All right, number 2, it says the waiting time for table is at least 20 minutes. So if you're thinking, all right, we're going to have to be here at least 20 minutes, that means it could be 20 minutes exactly, or it could be more than 20 minutes. So that means the waiting time is greater than or equal to 20 minutes. So the amount you're waiting compared to 20 minutes, this is going to be either equal to 20 or it's going to be the bigger amount. For number 3, the price of all special dinner entrees is below $10. So we're comparing the special dinner entrees to $10. So if you think about that, are we going to pay exactly $10? And in this case, they're saying it's below. So you can also look at your chart here and you can see the symbol, it's less than. So that means the special dinner entrees have to be less than $10. They could not be $10 in that situation. And then number 4, it says the Yoshida family spent more than, key phrase, more than $40 for dinner. So what they spent, the Yoshida family spent so many dollars compared to 40. More than is right here. So that means what they spent is greater than 40. This is the bigger amount. So we're going to have a greater than 40. All right, so those are just some basically just real life examples of when you would use these comparisons. We just don't always write it out in terms of math symbols. Now we're going to add one little extra piece, and we're going to add on there, we're going to throw a variable in there because we're talking about algebraic topics, so we can have algebraic inequalities. So let's look at each of these examples again. Now what they did was list out a phrase compared to a number. So let's change that. Instead of having a phrase, let's make it a variable. So we'll say the number of people seated in the restaurant. We're going to say P for people. P stands for the number of people seated in the restaurant compared to 200. And it's going to be the same situation. The number of people seated in the restaurant has to be less than or equal to 200. So it's 200 or less. The waiting time for a table is at least 20 minutes. So let's say W for waiting time compared to 20 minutes. Well, the amount of time you wait is going to be 20 minutes exactly. So we'll put our little equals, half of an equal sign in there. Or the waiting time is going to be more than that. It's going to be greater than because it's 20 minutes or more. So that means the waiting time is greater than 20 or it is equal to 20. Number 3, the price of all special dinner entrees is below $10. So I'm going to say, we'll say E for entrees compared to $10. Well, the entrees have to be under $10 or below $10. That means E, entrees, the price of those special dinner entrees is less than 10. And then number 4, the Yoshida family spent more than $40 for dinner. We'll call that D for dinner. And that is compared to 40. So the amount they spent on dinner is actually more than $40. So all of these are examples of algebraic inequalities, where you're comparing the variable, which stands for something, just like I did before, compared to a number. Now, the hard part with this, depending on the situation, is, let's say, let's take this one for example. If the dinner entrees are less than $10, there are so many possibilities for how much that dinner could cost that there are too many to list. It could be $9.99. It could be $9.98. It could be $9.75. It could be just $9. It could be $8.50. It could be $7.25. It could be $6.44. We could keep going on and on and on and on for a very long time and not list all the possible prices for those dinner entrees. And that's the way any inequality is. If I want to know what are all the numbers less than or equal to 200, well, there's a whole lot of them. Too many to list. If I want to know what are all the numbers greater than or equal to 20, there's a whole bunch of those too. Too many to list. If I want to know all the numbers greater than 40, we could go on and on and on forever and never list all the possibilities. So what we do instead when we have an inequality is we use a graph, and that graph is always just on a plain old little number line. So let's look at an example. Let's take the greater than. This says x is greater than 3. That means I want to know what all the numbers are that are greater than 3. Well, if you really think about it, you've got 4, 5, 6, 7, 8, 9, 10. But there are so many decimals and fractions that are between all those numbers too, we can't include them all. So we use a very simple type of graph to say, all right, everything that's shaded in, every place that I drew that line, that's covered by that line, that's included. So we use two different things. We use either an open circle, and we know it's open because it looks like an O, or we use a closed circle, and closed just means it's filled in, like that. Okay? Now, if it's open, that means I'm not including that number. So if I'm looking at x compared to 3, if x is greater than 3, that means 3 is not one of the answers, but anything bigger than 3 is. So what I'm going to do is I just draw a simple number line. Here's 0, here's my negatives, here's my positives, and on the 3, I'm going to put an open circle. That tells me that 3 is not included. Open circle, so it's not shaded in. And then I have to think, well, where are all the numbers that are bigger than 3? Well, they're to the right. So from that little open circle, I draw a line with an arrow to the right. So my graph looks like this. Open circle, arrow to the right, which is already drawn on your paper. Now, if I have all the numbers greater than or equal to 3, that's x is greater than or equal to 3, that means 3 could be one of my answers. So the only way I change that is, instead of using an open circle, I use a closed circle to say, okay, well 3 is part of my answer set. It's called a solution. So 3 is a solution, so I'm just going to fill that in. And then all the numbers that are bigger than 3, greater than or equal to 3, are to the right. And then, same thing, all the numbers less than 3. Well, is 3 one of my possibilities here? And hopefully you said, no, I want anything smaller than 3. So that means I use an open circle so I don't fill it in. And then all the numbers that are to the left, to the left, to the left, everything you own in a box to the left. Everything to the left is smaller than 3. So wherever that line goes, that's hitting every possible number that is smaller than 3, and then we put an arrow on the end to say, oh, just keep on going because it never ends, just like the number line. And then last, if we have all numbers less than or equal to 3, that would be 3 or less. So that means 3 itself is one of my answers. So I fill that in with a closed circle, so color it in, and then everything to the left of 3, and then I draw my arrow to the left. And that's how you graph an inequality. It's a really pretty simple idea, but it has a few things to remember here. Okay, so I think I jumped ahead of myself. Oh yeah, here we go. Here's what I want you to do. On the back of your page, number 5 and number 6, this will walk you through step by step how to graph the two inequalities given, this one and this one. So you can go ahead and pause me and do those two on your own and then check back as soon as you're done and see if you got them right. Oh yeah, pause, pause, pause. All right, so let's see how you did. Now I drew mine a little bit above the number line. You can draw it on it or above it, just as long as it's very, very easy for me and you to see and read. So I did mine above just to make it a little easier. So I want all the numbers, x stands for all the numbers that I'm looking for, that are greater than -4. So I want -4 is not going to be one of my answers because I only want things that are bigger than -4. So that means I put an open circle on the -4, and then everything bigger than -4 is to the right. So I draw my arrow to the right. On number 6, x is less than or equal to 1. So you have to ask yourself, could 1 be one of the answers? And in this case, the answer would be a big fat yup. So 1 is an answer, so I do a closed circle because I'm including 1 in my answer, and then I want everything smaller than 1, which is to the left, everything you own in a box to the left. And there you have it. It's just that simple, people. Okay, so I'm going to skip through this next section. We're going to get that in the next video. But what I want you to do is you can do number 9 and number 10. Go ahead and do those. And then you have a sheet that says 11-4 practice B. You can do 1 through 8 right now. So if you haven't, just as a reminder, if you remember on these, there's a little note on your paper that tells you this, but I want you to use an algebraic variable. I want to use a variable in all of these. So figure out what variable would stand for what you're comparing, like we did on those very first 4, how we came up with a variable after we did it. So I want a variable with some greater than, less than, greater than or equal to, or less than or equal to, some sort of inequality compared to a number, and those 4. And then down here on 5 through 8, you're going to have to number your own number line. Just put the numbers on there that you need. Put at least 5 or 6 numbers. You don't have to fill them all in. and then you need to graph those 4 inequalities based on where all of your answers would be.